Every once in a while, a piece of technology comes along that feels like it's straight out of science fiction. We're talking about a shift as big as going from mainframes to PCs. Well, get ready, because we're about to see the dawn of the desktop quantum computer. Can you even picture it? Computers used to be these massive, room-filling beasts that only a handful of experts could ever touch. And for the longest time, that's exactly what quantum computing has been like. But that story is starting to change right now.
So, to really appreciate just how big a deal this is, we first need to understand the status quo. Let's call it the quantum mainframe era, where these incredible machines have been locked away, totally out of reach for most of us. Okay, so what are the big hurdles with these traditional quantum computers? Well, first off, the cost is just astronomical. We're often talking over $1 million. They literally fill entire rooms. And here's the kicker. They have to be cooled to temperatures colder than deep space, near absolute zero. That means they need constant, expensive refills of liquid helium and nitrogen. So for pretty much everyone, the only way to get near one is through the cloud.
All right, so if that's the quantum mainframe, then what in the world does the first quantum personal computer look like? Well, a company called SpinQ Technology has an answer, and honestly, it's a total game changer.
Just look at this thing. This is the SpinQ Gemini. It's a real working quantum computer that can sit on your desk. No crazy web of wires, no giant cooling chambers, just this sleek little box. It's wild.
And the first thing that just blows you away is the price. We are going from over $1 million for one of those mainframe-style machines to under $50,000 for this one. Now, that's still a lot of money, for sure, but it is a massive, monumental leap in making this technology accessible. And then there's the size. It weighs about 55 kilograms, or around 120 pounds. So yeah, you're not going to carry it around in a backpack. But it's fundamentally portable. This is a machine you can actually ship to a school or a university lab without needing a whole construction crew to install it.
So how on earth did they pull this off? Well, this is the secret. The Gemini operates at room temperature. That completely gets rid of the need for those super complex $1 million refrigerators and all that liquid helium. This one single fact is what makes the whole desktop idea even possible.
And this isn't just a one-off prototype. SpinQ has an entire lineup of these portable quantum computers. You've got the Gemini Mini, the Gemini, and the Triangulum. The fact that there's a whole product family shows you this is a serious effort to build an ecosystem for students and researchers, not just some lab curiosity.
So what's the secret sauce here? How do you shrink a quantum computer down and completely ditch the need for extreme cold? The answer lies in a technology that's actually been around for a while, but it's being used in a really clever new way. It's called nuclear magnetic resonance.
Okay, stick with me here. Imagine you could literally talk to individual atoms. That's kind of what NMR does. It uses powerful magnetic fields to control the natural spin of an atom's nucleus. By sending precise magnetic pulses, you can flip those spins up or down, basically turning them into qubits, the fundamental ones and zeros of a quantum computer.
Now, this diagram might look a little complicated, but the core idea is actually pretty simple. Everything you're seeing here is designed to do just one thing: talk to the atoms inside a tiny liquid sample and get them to perform calculations for us. You've got permanent magnets to create a stable environment, and then radio frequency coils that act like a transmitter and a receiver, sending in the instructions and listening for the results.
Let's just break it down into 3 easy steps. First, the magnets align the nuclei in a special liquid. Second, carefully timed radio pulses are sent in to flip the spin of specific atoms. This is how you perform the actual quantum operations. And finally, a coil listens for the tiny signals the atoms send back out, which gives you the answer to your computation. Align, manipulate, and read. That's it.
So, what's it actually like to use one of these things? Do you need a PhD in quantum physics to even turn it on? Turns out, not at all. This is the software. It's called SpinQuasar, and this right here really shows you what they're going for. It's a visual, drag-and-drop interface. You can literally build a quantum circuit by pulling different gates onto the screen, and then you just hit run and it sends it to the real hardware. It even has a simulator built in, so you can check your results.
Now look, this is a 2 or 3 qubit machine. It's not going to be breaking any encryption anytime soon. But it is powerful enough to run over 10 of the most famous and important quantum algorithms out there. We're talking about things like the Deutsch algorithm and the Grover algorithm, which prove quantum computers can solve certain problems way faster than classical ones. It's a perfect tool for demonstrating the weird and wonderful principles of quantum mechanics.
You know, this quote from the creators really nails it. They see this device as having a dual purpose. On one hand, it's a super friendly platform for a beginner who just wants to learn the ropes. But on the other hand, it's also a legitimate scientific instrument for researchers exploring the field.
So, what does this all mean for the big picture? This isn't just about some cool new gadget. This is about democratizing access to a revolutionary technology. Think about it. When you put a powerful new tool in the hands of thousands of smart, creative people, they are going to find uses for it that the original inventors never even dreamed of.
And here's the crucial point. The #1 goal right now is education. It's all about giving students real, hands-on experience with actual quantum hardware. You can't really train the next generation of quantum engineers by just having them log into a website. This is like the difference between reading a book about how a car engine works and actually getting to take one apart and put it back together yourself.
And this right here, this is the mission statement that just ties it all together. The hope is that by making these machines affordable and portable, we can prepare a whole new generation for a future where quantum tech is everywhere. It's about building that foundational knowledge right from the ground up.
You know, the very first personal computers were nowhere near as powerful as the mainframes of their day. But they completely changed the world because they made computing accessible. They put the power to create into the hands of everyone, and it sparked a revolution. So the big question this little box asks is this that moment for quantum computing? Is this where the real journey begins?